going to look at this video is a couple of things related to writing a lab report, some of the intro stuff. We're going to talk about making tables and graphs. We're going to talk about reporting appropriate significant figures in those. We're going to talk about using the equation editor. And then finally, what do the results look like? Like, how do you actually structure this? Those are the things we're going to go over in this video. So let's start by talking at tables. So for a number of the early labs, what you have to submit, one of the three things, the first thing in the first few labs is to submit a table. A table has a few parts. So first, to make one, if we can either copy and paste one from Excel, like if you already have some information there, you can copy and paste it into Word and then do manipulations with it. But if you need to make a brand new table in Word, we can go up to Insert. There's a thing for Table, and we pick a size that's appropriate for what we're working with. Let's say this was appropriate for what I needed to make. Note that your copy of Word might look a tiny bit different, but it'll have the same feature. So first, I want to think about what I need to put in it. So for example, maybe here I have a mass of water, and then we're going to look at some formatting stuff in a second. We've got a volume of water, and then we have air. Now, one thing you'll notice is that this doesn't look so great, and I've got trial number. So I've got these two extra columns right here, so I shouldn't keep those if I don't need them. So I can right-click, and I'm going to delete those columns. I can then, if I go to the bottom right here, I can make adjustments like this, where I change everything. So now I've made it larger, and now I've got enough room for everything to show up appropriately rather than being spread out across two lines. I also need to put units with these. So my mass of water is going to be in grams. My volume is going to be milliliters, and I'm going to report air in milliliters as well. I also can probably shrink my trial section. It's not going to need as much room, whereas the other three should all be fairly similar in space. So let's say I did 4 trials, or let's say I did 3 trials, and then I'm going to report some averages at the end. So I'll do 1, 2, and 3. So let's say we made some measurements like 48.564, 47.598, and then 48.216. So these aren't specific measurements from any lab. They're just some numbers I came up with. And then if we wanted to do that, we would then fill out these next 2 areas here. We would have volume of water. And if there's going to be some error measurement, like let's say we're comparing this to an expected measurement, we're probably subtracting it from some volume. For example, if we were using a 50 milliliter pipette, we would be taking the new volume we get and subtracting that. Then I would report something down here, like maybe I would have an average, and then I would actually have to find the value, put that in, and then I would put that there. If I was going to do an average for all 3, it would be appropriate to instead write average over here. And then I could put an average in all 3 areas. So you choose how to label things based on what looks the cleanest with what you're working with. So that's what you want to think through. So you want to fill all of these out. Do make sure when you're doing this that you pay attention to your significant figures. So if I put 3 significant figures in this mass of water, that should be how well I know it based on the scale I used. If I used an analytical balance, for example, that went to 4 decimal places, so 6 total sig figs in this case, I would have some additional digits. So I'll fill those in like I'd measured them. Don't just make them up. Have them be something you recorded. But it's important that you be consistent with what would make sense. So if you were to multiply the density of water times the mass to get the volume, it would be important that you also report it to 6 significant figures. It wouldn't make sense to have a volume now that now had 10 significant figures because, well, density was measured to a really long decimal, so my calculator gave me 9 decimals, so I just put them all there. That would be inappropriate. So you need to take into consideration what your significant figures were in your calculation to make sure they make sense for each thing in your table. That was one of the errors I've noticed some in early labs, was just there were problems of reporting way too many significant figures. There's something you don't know. And more rarely, but still happened, where people would remove significant figures that it was inappropriate to do so. So make sure if you made an accurate measurement that you don't just cut it off at the middle somewhere for no particular reason. It's also helpful to note that for a table, it will tend to have it should have a title. So this is my table 1, and in this case, it was, let's say, calibration measurements for a 50 milliliter pipette. It should be fairly short, and it should clarify with what you're working with, and it should be clear from your title what it is this is a table of. Tables tend not to have much other information because each of the titles is going to be descriptive. In some instances, You might need to add some additional information about this mass of water, for example. If so, it's appropriate to put so I go to mass of water, to put a subscript, and I would put a little a there. And then down below, in small text, I can write a, and then explain what it was. So maybe I wanted to make a designation about the temperature of the water, for example. I could make a note and make that there. Note, you're not going to always need that in tables, but occasionally there'll be additional information that would be appropriate to include below. That would be a way to do that. If there's some additional descriptor that would make it so it was really, really long inside the table, that would be inappropriate. So you might need to do that. That isn't going to come up all the time, but it's just something to know that you can do. You'll also notice that this doesn't have a caption below. So for tables, you're just going to have a title, and then you'll have your table. Now, on the other hand, if you were to make let me fix that. So there we go. And back over. So if you were to have a figure here instead, I don't have one pre-made, but like if you have a graph that you inserted, you do not title graphs as your way of identifying them in science and chemistry literature. I know that you may be used to from previous labs, like I know some of the early Gen Chem labs or maybe high school labs. It was real big. Make sure you've got a descriptive title. That's not actually what we do. Instead, we do create a graph. If it's appropriate, there will be a legend. Sometimes you don't need, a lot of times you don't need one, but occasionally that can be appropriate. But the other thing, you'll have really well labeled axes, so make sure X and Y axes have units as appropriate and they're labeled correctly. And then what you'll do is you'll write a caption beneath. So you'll call it figure 1. So you'll have figure 1, and then you'll write out a description of the graph above. And in some figures in scientific literature, you'll see like 4 different graphs all together in a big group, and then it'll have a description for each of them. They'll probably be labeled A, B, C, D, and they'll describe what each of them did in detail. Now, for copyright purposes, I'm not grabbing something from a piece of literature to do, but if you go and you look at chemistry articles in the Journal of the American Chemical Society, for example, you will see plenty of examples of figures where they have these big long descriptions that are 5 or 6 sentences long even. The reason for this is that figure caption should be sufficient to describe that graph, even if I haven't read the rest of your paper. It should be context. It should be enough for me to figure out what that figure means. In this lab, you're unlikely to have quite that long of a description, but you will need to have a short description to describe what it is. You do that instead of using a title. That's what we do in chemistry literature. So that's for our tables and figures. So as a reminder, make sure that your significant figures are done appropriately. Make sure that your formatting makes sense. It should look nice. You shouldn't have extra columns where they don't need to be. You shouldn't have sizes that don't match up with what you're working with. You should make sure you have units as appropriate, and it should be well organized. Like, it should be aesthetically pleasing. That's something to think about with it. Now, in terms of demonstration, this particular formatting that is the default for Word is something that I basically would never see in a journal. So if I go up to design, I can choose other formats for it. And so I'm much more likely to see something, let's see. Let me find the one I tend to use. So there's a bunch of different ones. Like I tend to see something like this that you'll notice. I don't actually have the up and down lines. That's very unlikely for you to do. You tend not to see those. We instead rely on them being in the right columns. So I'll tend to set it up using this format to get everything in the right place. And then I'll switch to this. And there's a bunch of different ones. Use one that looks reasonable. Basically, the boxes can be distracting and they don't really serve a good purpose. Let's see. Another note is it is appropriate to, when we do something like this, you will tend to center justify this rather than left justify. So that's under home. We'll set up here. It's centered. That's common. You'll also see some that will be right justified. In a journal, you would look up what your journal rules are. I can't remember the ACS style guide off the top of my head, which it was. I believe it's center justified, but if not, I'll let you know in class. We can correct that statement. But basically, try to make it look good with the part on top, and that'll work out well with it. So that's for tables and figures. So a few other comments I wanted to make was for calculations. So you have to use an equation editor in this class. So this tends to show up under the insert menu. So this does require you have a downloaded version of Word. You cannot do this on like the website version of Word that you like go to through a browser. You have to have a version installed on something to use this. So under insert, I'll have this thing for equation. I've got a bunch of stuff here, but I actually just click this little pie looking symbol and it adds an equation here. And it gives me a bunch of options. So the main things we tend to use are you'll use a lot of fractions because you'll have a lot of equations that are set up. So you've got something in the numerator and denominator. I'll do a simple equation. Let's do the molar mass equation. So first I'll write molar mass, and it is equal to, and it's a fraction, so I'll make a fraction bar. And that will be the mass in grams of my sample and the moles of my sample as appropriate. And so that will give me my molar mass in grams per mole. Now, you can obviously do more advanced things with this. So for example, let's insert a new equation. And let's say instead you needed to have a radical. For example, you're doing something with confidence intervals. So I need to take the square root of something, because maybe I'm calculating my standard deviation. Then I can put whatever I need to inside of here. For example, let's say I'm calculating something based off the average. So I have my 48.5643, and then I'm subtracting whatever my average ends up being, which is going to be some number. I haven't calculated it. So I'm just going to say 48 point. I have no idea what that is, so we'll just put in some numbers. That, and then I need to square that. So I close the parentheses. I can then go up to script, and I can add something like this, and this will allow me to square things. Or I've got some common ones that I use often. So this, you'll notice it creates this box that's kind of up, and this box that's there. So I actually need to cut and paste this. So I'm going to remove that, Control X, and then press Control V to paste it inside this little box. And then up here, I'll put a square. And then after that, I put a subtraction sign because I'm going to, or an addition sign, because I'm going to add some stuff together. And this time I remember that, oh, I need to do the script first. And then I'll put my next number in here, like 47.5985 minus, and I'll continue going that way. And you can add a bunch of stuff there. And then I have this now is just things in a numerator. And you can continue with that. You see the idea. But let's say that I needed to do this, but also needed to have a fraction. Well, I can put a fraction in. And then inside there, I can put my radical. And then I can put my values in here. And now I can divide by n if I needed to do that. Or, as is often the case, let's say I needed to do a fraction inside the square root because both the top and bottom need to be done. We can insert another equation. I can have the fraction. I can have the radical first and then put a fraction inside of it. And now I've got my square root in, and I have my equation I can put in for standard deviation for each measurement. With these, what's important to remember, so that's just a bunch of examples, is 1, make sure to label your equations using names for the first line. What I mean by this is do not simply put a bunch of numbers into an equation as your first step. Your goal of this is to show me you know what you're doing with this. This helps a lot in case you make a small mistake. I would like to know, is it that you incorrectly put in your volume for water instead of mass of water, or it's that you didn't realize that's what you're supposed to do, and in the equation you actually put volume of water. By labeling things correctly, it helps me know more so that I can give better feedback on your lab, and it makes it more clear for your audience as well. So in your first line, give a description using words or variables. If you're using variables, appropriately identify what they are, especially if there's something that we don't use a whole lot. Like if you've got an x you've added to your equation, make sure it's clear what x is. So if you clearly delineate that, it's good practice, helps us work with that. Some things are very, very commonly used. I'm not going to give you a hard time if you didn't label the fact that n here is number of samples. That's assumed within a standard deviation equation, but it might not be a bad idea just to help with clarity. Over time, you will learn as you're working with things when do you need to put a label and when are you just fine just to write everything out. But that's a case where it can help for how clear you are. And then after you make sure to label each line, then fill in your values in the next line. And then at the end, make sure to use appropriate units. And the whole time, think about appropriate significant figures. I shouldn't see any standard deviations that are 12 digits long, 12 sig figs long when you have a measurement where you only have 4 sig figs. That just doesn't make sense with that. So keep that in mind as you do this. This helps make sure your calculations are clear. The goal of this class is not for you to show every single calculation every time. You are to show single example calculations to show you know how to do something. For example, in this case of this table up here, if we'd finished working on it, if you had to do something where you had to convert from mass to volume of water and you wanted to show that, you would only need to show the equation once, where you use density. And then after that, you wouldn't need to show it for every single trial. And in future labs, if the same calculations come up, we're not going to require you to show them a second time. For each lab, I will help to identify if there are particular calculations I want to make sure that you show. On occasion, I might ask you to repeat one you've done before because there is something else present that you might not recognize. I want to make sure you're doing okay with it. So that could come up in some. Make sure to pay attention to that. After the calculation sections, I'll have recommended ones if there are particular ones you need to make sure to include that you might not think of to otherwise. Finally, I want to talk about what a results section is. So In the results sections, you'll notice in my directions, I mentioned usually like 1 to 3 sentences. In many cases, it'll be 1, maybe 2. So I'm going to use the early pipette lab as an example. Let's say I made some measurements and I wanted to report my results. Here's an example of what I could say. I could say that in this experiment, the pipette, I did not pre-write this, I have to think through it for a second. The pipette was found to, I'm trying to word this better. See, you get to see the thinking process for us too. Basically, I want to report what I actually measured, which is the volumes of the water from the pipette, and then how does that compare to the expected value on my cameras over here. So I've got 2 things I want to say, and I'm really only going to need 2 sentences here. So for example, this experiment, the pipette was found to dispense, let's say my measurements, this obviously is not for this data set. This I'm going to do for the 10 milliliter pipette that you guys work with in lab, so this does not match the table up above. But let's say I did that I got the results dispensed 9.9564, and then plus or minus. So we have the insert here, symbol, I've got a plus or minus symbol. 0. Let's say I got 0.1204 milliliters. So I dispense this many milliliters. And now, that's my first thing. I just need to say, hey, this is what we found. Our pipette was found to dispense this. And I should say 10 milliliter pipette to be clear. The 10 milliliter pipette was found to dispense this volume. This matches with the expected range, or the expected value for the 10 milliliter pipette, which should dispense 9.98 to 10.02 milliliters. Or to be consistent with what I just said, 10.00 plus or minus 0.02 milliliters. So that's what a 10 milliliter pipette, at least the transfer ones we were using in lab, is expected to dispense. The reason I can say that this matches, well, this word matches isn't probably ideal, so it's okay. The reason I can say matches is this range. What it means is that my pipette distributes 9.9564 plus or minus 0.1204 milliliters. So there's a range. That range overlaps this range here. This range goes down as low as 9.98. And if you look at this range is going to include 9.98 in its range. So the fact that the 2 ranges overlap means that we can say that we don't have any evidence that there is statistically significant difference here. Importantly, this does not say that I can disprove that there is a difference. So this is not, we don't have the tools with our statistical analysis to say that there is no difference at all with my pipette compared to what is expected. I can't say that. But what I can say is that at the 95% confidence level, that's the other thing I would add here. It was found to dispense 9.9564 plus or minus this at the 95% confidence level. At the 95% confidence interval. So that's what we're able to say. And so that tells us what we can say is that we don't see a statistically significant difference. Because there's range overlap. If there were no overlap at all, and what I mean by that is, let's say that I got a very different value. Let's say instead of 9.95, let's say that was actually 9.4564. I got really far off. The highest value is around 9.57 with 2 more decimals. 9.57 does not fall anywhere within the 9.98 or the 10.02 range. So even the highest point in this range doesn't fall within the 10 milliliter pipette range. At that point, I would say their expected values do not match, and there's an issue somewhere. Realistically, it is likely an issue that I have made an error in making my measurements. It is also possible that there's something wrong with my pipette. So it's either there's a problem on my side or on my device side, or maybe I'm making something about my measurement wrong. Maybe I'm not actually transferring it correctly. So there is some problem there that I'm not getting the accuracy I would expect within the amount of evidence I looked at. So I know that was a little bit of time, but hopefully it helps a bit with thinking through how to write these lab reports, how to think about how to construct tables and graphs, how to set up stuff in your equation editor, and then what actually belongs in the results. Because you don't need anything else of this in the results. We don't need a bunch of stuff about how, I learned that pipettes are hard to use, or I learned that that water has to be measured very carefully or else there are errors. Things like that might be appropriate for a conclusion if you are writing something more elaborate. This is a lab that's very straightforward in terms of what we're doing. We are not making a unique contribution to the world, and that's okay. So our results is just going to be really straight and to the point. So with that, I hope you're doing well, and I will see you in lab.